Hello, welcome to AP Pre-Calculus. Today's lesson is 3.2, Sine, Cosine, and Tangent, Part 2. Reminder, in the coordinate plane, an angle is in the standard position when its vertex is at the origin, and one ray of the angle lies on the positive x-axis. The terminal ray is the second ray of the angle in standard position. The figure above shows an angle theta in standard position. So positive and negative angles, what are those? So positive angles go in a clockwise. So if I start here, like if we close this back down to here, it would be a zero angle. Both rays are on top of each other. And if I start moving the terminal ray, start going up, that should make sense. That's a positive direction. Up is positive. And if I keep going around the circle, that would be a positive direction angle. It goes counterclockwise. And obviously, a negative angle would start by going down and go in a clockwise. The arrow up here tells you which way we went. It's kind of obvious, but I had to say it. Since we're talking about angles in a coordinate plane, kind of like a clock hand can keep going around and around and around as many times as it wants, we have a periodic behavior. Like I can stop at 45 degrees a lot. And that might be the last time you hear me say 45 degrees because in higher level math classes, we kind of go away from degrees and start using a thing called radians that we'll talk about in just a second. Okay, so if we look over here, it says the measure of an angle indicated in the figure on the left is its arc length divided by radius. So this is the arc length. It's part of the circumference, and then we would divide it by the radius. Okay, and that's what's called a radian. When you do arc length divided by the radius, that is called a radian. So if I went halfway around a circle, that would be 180 degrees, right? But let's say that the circle had a radius of 10. What is the circumference? Well, that would be 20 pi, 2 pi r. Remember that guy? So if I came all the way over here to 180 degrees. Well, how much of the circumference did I go? I went 10 pi. And then if you divide that by the radius, that's leaving pi. So this would be pi radians. All right. So I went 180 degrees if I were measuring the angle in degrees, but I went pi radians if I was measuring in radians. Okay. Okay, so consider angle theta created by the quarter circle of radius 4 above. Find the measure in radians. So we're going to do this the long way. I'm hoping here in the near future you have some of these memorized, but let's do the circumference of this thing. So the circumference is pi d, or 2 pi r, right? So we know that it is 8 pi, and I only want to go a quarter of it. What do we have there? Well, that's 2 pi, right? So that's the length of this that part of the circumference is 2 pi. So if I divide it by the radius, I get pi over 2. Okay? So this is pi over 2. In the last question, they gave us a graph. And we had to come up with the arc length and the radius and find the angle measure in radians by looking at a graph. This one is words. And I'm going to tell you, if you want to make a graph, you can definitely make a graph. But you got to be able to read the whole thing and understand what's going. And the graph might be helpful because I'm going in a clockwise direction. So there's what the graph would look like. Notice I put the arrow on there to show that I'm going in that direction. Okay, and I know that my radius is 3. So let's do our circumference, 2 pi r. But because we are going in the clockwise, that's going to make this a negative 2 pi because we're going in the negative direction, okay? So now we're going to do negative 2 pi times 3. That's going to give us negative 6 pi. That's the circumference of the whole circle. I want a third of that, right? So a third, that's going to give me negative 2 pi. So that's like me going right about here, right? Maybe a little bit further. So that's about a third of the circle. So this is arc length. And we're going to divide it by the radius. And when I do that, we get a radian measure for our thing. And there's not much we can do this. It's just negative 2 pi over 3 radians. So now we're going to start talking about the unit circle, which is a huge deal moving forward in your math career. We have to have a lot of the unit circle memorized, and when we look at this in a little bit, it's going to look overwhelming, but it's not all that hard. But before we get to the unit circle, I want to talk about how we're getting these numbers first. So let's look at this circle on the left. If I'm right here, I'm at 0. And we're not going to talk about degrees here, guys. It is 0 degrees, but we're not going to talk about degrees anymore. We are talking about radians. So right now I'm at 0 radians because I don't have any part of the circumference. And if I go all the way around the circle, if I start here and go all the way around the circle, I completed the whole circumference. So I did the whole 2 pi r around. And if I divide by my r to get to radians, remember, circumference, arc length, divided by radius gives you radians. These will cancel out. So 0 and 2 pi are the same thing. And remember, this is a cyclical idea. It is a periodic function. So I could go around again, I'd be at 4 pi. I could go around again, I'd be at 6 pi. I could go around again, I'd be at 8. They're all the same values because this is periodic. So what if I only went halfway around my circle? Where would I be? Well, if all the way is 2 pi, it should make sense that half is pi, right? And what if I went around the circle again? It would be at 3 pi, and then it could be at 5 pi. I could be at negative 1 pi and negative 3 pi, right? So what if I only went a quarter of a way? So if halfway is pi, then what's half of halfway? So if half is pi, half of that would be pi over 2, right? And then down here would be 3 pi over 2. So those are our major axes points in the unit circle. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And again, we could just keep adding 2 pi to these numbers because it just keeps going around, and 2 pi is all the way around the circle. So these angle measures are for any circle, right? Any circle, doesn't matter what the radius. But we're going to be talking about the unit circle. And why do we call it the unit circle? And the reason we call it the unit circle is because that its radius is always 1 unit, okay? So the concept of this unit circle will become pivotal throughout the rest of this course because of its incredible usefulness when working with trig values. And not only this class, it is huge in AP Calculus and above. Example 3. For each of the following, sketch a picture of the arc length described based on a unit circle, then find the measure of the angle corresponding with the arc length. All right, so I have some circles here. If I want 1/6 of the unit circle, meaning 1/6 of all the way around, where would you think I would be? We know that this up here is 1/4 of all the way around. So 1/6 is probably going to be in here somewhere. And what is going to be the value of that? And actually, that's probably a little bit off. That looks like 1/6 is not very much. So we got that. So we're going to go 2 pi. And I went up because it says counterclockwise. 2 pi is the distance all the way around. We multiply by 1/6. That's going to be pi over 3. How about B? 2 full revolutions in the clockwise direction. So I'm going to go around once. That's going to be negative 2 pi. And around again, I'm going to be at negative 4 pi. C wants me to go 3/4 of the way around the circle. Well, here at pi, how far around the circle did I go? Well, I went halfway around the circle, right? So I didn't quite get there. 3/4 is going to be right here, right? So I'm going to go around. So I'm talking about this line right there. So I'm going to do 2 pi times 3/4, and I get 3 pi over 2. All right, last one, 7/8 around there. Well, this is halfway around. 7/8 of the way around, I don't know, might be somewhere in that. So we're looking for that guy right there. So we're going to do 2 pi, and it's positive because I went in the counterclockwise direction. Multiply by 7/8, and I get 7 pi over 4 for that guy right there. This is the beginning of our unit circle that we're going to have memorized. And already it probably looks a little daunting to some of you, but it's not all that bad. So we're going to fill in all of these blank spaces with their radian angle measure, okay? Some of them we already know. We already know that this guy over here is pi. And we know that this guy down here is 3 pi over 2, okay? And we also know that this guy is 2 pi, all right? So whenever your denominator is a 1 or a 2, we know that our our angle is on one of the x or y axes. If it's anything else, 2, 3, or 6, it's in one of the quadrants, okay? So I'm going to try and come up with some helpful tips on how to fill these in, and I'm going to look at all of these numbers. Like, I'm going to start with the pi over 6. So I want you to look, can 4 go into 6? No, it can't, right? Can 3 go into 6? Yep. Can 2 go into 6? So I'm going to move around this circle, hitting those lines, which means I'm going to skip this line, this line, this line, and this line. Why am I skipping those? Well, because 4 doesn't go into 6, so it's not going to work out for me. So I start with a 1. All of these in the first quadrant, it's nice. All of them have a 1, right? So we're going to count. We're going to start with 1 over 6, and we're going to count 2 over 6, 3 over 6, 4 over 6. And I'm going to keep moving to the next angle that's not red. So I'm starting here. You're with me? 1 pi over 6. 2 pi over 6. Well, that reduces down to 1/3. 3 pi over 6. Well, that reduces down to 1/2. What is this next one? 4 pi over 6. Oh, crap. Well, that reduces down. And that reduces, but we're going to leave it just for a second. So then I got 5 pi over 6. Then I'm here, 6 pi over 6. Well, that's pi. 7 pi over 6. All right? Now we're here, 8 pi over 6. We'll come back to him in a minute. 9 pi over 6 reduces down. 10 pi over 6. 11 pi over 6. And then I'm back here at 12 pi over 6, which reduces down to 2 pi. Okay? So let's go back to those ones that can reduce. So what happens to 4 pi over 6? Well, I can reduce that to 2 pi over 3. What happens to 8 pi over 6? Well, I can reduce that to 4 pi over 3. And we go around and we reduce the ones that we can reduce. And the last one's going to be 5 pi over 3. So notice, in every quadrant, we have 1 pi over 6 and 1 pi over 3, right? We just got to get them in the right spot. So let's go back and do the pi over 4s, and we're going to do the same thing. Since 2 can go into 4, we're going to count these guys too. We're going to count the axes when we count. So let's count. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4. 4 pi over 4, 5 pi over 4. 6 pi over 4. And our last one is 7 pi over 4. So hopefully you only have to kind of do that once or twice with doing all of that garbage, because at some point you're going to just start remembering it, because we're going to use it so much in the next couple of years that it should become second nature to you. So don't freak out. So look what we got here. We're talking about sine, cosine, and tangent of the unit circle. And what do we notice about sine of theta? Why it says sine of theta equals y. What are we missing? Well, we're missing our radius, right? Isn't it supposed to be y over r? But because it says unit circle, we know what the r is. The r is 1. So I don't have to put the r. So in the unit circle, sine is only y, and cosine is only x. Tangent is still y over x, or sine over cosine, but we don't have to worry about the r, because the r will always be 1 in the unit circle. And that's going to help us with memorizing some of the quantities that we need to remember for sines and cosine of those special radian measures. All right, example 5. The figure shows a circle centered at the origin with an angle measure of theta in standard position. The terminal ray of the angle intersects the point P. The coordinates of P are 1/2, comma, square root of 3 over 2. Find the following values. Now, it does not tell me in the words what the radius is, but the picture does. It goes out to 1, 0, so that tells me this is the unit circle. So because it's the unit circle, I have an x value and a y value, and I know that sine is just the y value, so I know this is square root of 3 over 2. Cosine is just the x value of 1 over 2. Tangent, it's going to look weird. I'm going to write it bad at first. Square root of 3, because that's y over x. And then if I keep flip that, I'm going to end up getting square root of 3. By the way, if your denominators are the same, they're going to end up canceling out. But you cannot cancel out a numerator with a denominator or a denominator with a numerator when it's a fraction over a fraction. So be careful. Might be best just to keep flip and do it the old school way. But either way, you should get square root of 3. Last one. The point R is a result after P is reflected over the y-axis. Let alpha be the angle in standard position whose terminal ray intersects the circle above at point R, and then find the following values. So let's mark where that's going to be. So there it's reflected over the y-axis. So what is my new point here? Well, my y is going to stay the same because I'm at the same height. So the y is square root of 3 over 2. But what happened to the x value? Well, I went left instead of right, so that's a negative. So there's my new point. So I still have an x and a y, so this should be pretty easy to do. Sine is my y value, square root of 3 over 2. Cosine is my x value, negative 1/2. And tangent is my y over my x. Cross out those 2's. Don't leave the negative in the bottom. We get negative square root of 3.